Hi everyone. Today we're going to be talking about long division. This video is more of an update to the long division video I did previously. I hope the addition of new tools will help explain things better. So what we'll cover quickly is some terminology, and then I'll show you guys my method versus the typical method and the three rules that will help you solve any long division equation. Okay, so let's go to the terminology. Sorry, 1 second. Okay, so yeah. So typically, you in textbooks, division equations are written as follows, like 25 divided by 5, and you'd write the answer here, 5. Okay, so what you're trying to see is how many times does 5 go into 25, and this is the answer basically. Now these numbers, this one, and this one, have specific names, right? So this number here, 25, it's called the dividend. So that's the number that's like generally we're trying to see what number goes into it. This 5 here is called the divisor. And generally that's the number we're looking at to see how many times it fits into something. So that's generally, if you think about a pie, we can see like a slice being the divisor, and the total size of the pie being the dividend. So how many times does the divisor fit into the dividend? And this 5 here, it's generally called the answer, or more technically it's called the quotient. But for the most part in this tutorial we'll refer to this number here as the answer. So we're dealing with the dividend, the divisor, and the answer. Okay, now moving on to the typical method, as I showed you guys here, this is generally how division equations are written in textbooks or in questions, but which is all good if you're dealing with small numbers, or you know how to if you're dealing with small numbers and they fit perfectly into one another, but not so much when you're dealing with bigger, more complicated numbers that may not necessarily fit in with one another. For example, but I'll get into examples before, but let's look at how I would, or my method of solving division equations. So that this same method here can also be written like so. You've got the dividend here, you've got the divisor here, and you write the answer here. Okay, so we'll just color code this, so the answer goes here, and you got the divisor here, and you got the sorry, that's not the divisor, apologies. You've got the dividend and the divisor here. Okay, so in answering this question, 25 divided by 5, the answer would be 5, right? Great. Okay, so I hope that kind of clarifies the method I'm using. So this is my method versus the method you kind of see in textbooks. Now, let's just clear this up a bit. Let's look at potentially more complicated questions that may not necessarily fit neatly into one another. Now, in these, in the next part, I'm going to be introducing the 3 rules here. So this rule is called the remainder rule. Okay, so remainder rule. Okay, so this, suppose you've got an equation like 4,253 divided by, say, 3. Okay, so the first thing you do, we look at the divisor, and we look at the dividend. In particular, we look at the first number of the dividend starting from the left side, right? The first number on the left side. Okay. Is this first number bigger than 3? Is it bigger than 3? If it is, great. We don't need to... That's the only number we need to focus on at the moment. But suppose that number was, for example, 2, right? If it was 2, then 2 is less than 3, so we would have to look at combining the next number along with it. So we'd take the number next to it and would look at 22. Would focus on 22 as being the number we're trying to divide into. Okay, but let's go back to the original equation, which was 4,253. So we say our 3 times tables, okay, until we get as close as possible to 4, but not greater than 4, right? So as close as possible to 4, but not greater than 4. Okay. So 1, 3, 3, 2, 3, 6, right? So 2, 3 is 6. So 6 is greater than 4. So 1 times 3 is 3. And we'd write it down here underneath. So, alright, so 1 times 3 is 3. Okay. And we'd subtract it here. 4 subtracted by 3 is 1. Okay, and now we look at these numbers that are left. So we'd drop down 2 down here, so we would get 12. We only drop down the 2 here because remember the 1 by itself is less than 3, so we can't really use that number. It's not big enough. So if we drop the 2 down here, we get 12. So we say our 3 times tables until we get a number close to 12. So 133, 236, 339, 4, 3, 12. That number fits perfectly. So 4 times 3 is 12. Okay, now we subtract this again. So 12 minus 12 is 0. The 0 is less than 3, so we need to drop another number down here. So 5. So 5 is greater than 3. Great, we can use this number. So again, to repeat the same process until you get to the end. So closest number to 5 in your 3 times tables. So 133, 236. So it would be 133. So 5 subtracted by 3, 2. Is 2 greater than 3? No. So we need to drop the next number down. So 23. This number becomes. So what number in your 3 times table is closest to 23? So 133, 236, 339, 4312, 5315, 6318, 7321. 8324. 83 is too big, so 7321 would fit nicely. 7 times 3 is 21. Okay, subtract these 2 and you're left with 2. Okay, but now we don't have any more numbers left up here, right? So what can we do? Well, we can put a decimal point here. Okay, this decimal point allows us, so the decimal point allows us to borrow an extra 3 zeros. Okay, so now that we've got this decimal point here, right? We have 3 zeros we can use, and we'll put 1 0 next to the 2, okay? So this number now becomes 20. So what in your 3 times table gives a number closest to 20? So 7 3 is 21, 6 3 is 18, right? So 6 3 is 18. And subtract these two, you're left with 2. Again, we're going to need to use one of those zeros. So we've used one already. We need to use another one of those zeros, put it next to it, and again, repeat the same process. What in your 3 times table is closest to 20, right? So 6 3 is 18. Same process, you're left with 2, and we're using our last zero here, and again, you're left with 6. So 6 times 3 is 18. Subtract these, and you're left with 2. But now we've used up our 3 zeros, right? So what can we do? We put remainder 2, right? So the answer then equals, let's go back up, 1417.666 remainder 2. Cool. Brilliant. I'll just put the answer in red. Cool. So that's the remainder rule. Now I may have skipped ahead here, and I probably should have talked about the decimal rule to begin with, but nonetheless, so the next rule is the decimal rule, and that's basically the fact that after we've run out of numbers, as we did here with these, we can put a decimal. So the decimal rule is putting a decimal point in. So putting a decimal point when there are no numbers left allows us to use 3 extra zeros, right? And that's what we did here. So we used one of the zeros here, one of the zeros here, and one of the other ones here. So 1, 2, 3. So these 3 zeros, or the fact that we could use them, and only after we've put in this decimal point here, signifies the decimal rule pretty much. But let's go ahead and do another equation. For example, 245 divided by 2, nice and simple one. Okay, so again, 2, we look at the first number. 2 is equal to 2 here, so we don't need to combine 4 to make it 24. So 2 is enough. So we say our 2 times table till we get to 2. 1 2 2, 1 times 2 is 2. Subtract these 2, and you're left with 0. Drop down 4, and you say 2 times table until you get to 4. And so 1 2 2, 2 2 4. So 2 times 2 is 4. Subtract 4, and you're left with 0. Then you drop down 5, right? Sorry, it's a bit messy. Drop down 5, and you say your 2 times table until you get a number closest to 5. So again, that would be 1 2 2, 2 2 4, 3 2 6. 3 2 is too big, so you use 2 2. So 2 times 2 is 4. Okay, subtract 5 from 4 from 5, sorry, and you're left with 1. Great. So now putting the decimal rule, we've got no numbers left here. remember. There's no more numbers. So we can put a decimal point, and remember the decimal point allows us up to 3 zeros. 1, 2, 3. Okay, so let's use one of these zeros, put it here, and we're left with 10. Okay, so 2 times table until we get to 10 or closest to it. 1 to 2, 2 to 4, 3 to 6, 4 to 8, 5 to 10. So 5 times 2 is 10, and we're left with 0. So we don't need to use all 3 of those zeros in this instance, and the answer is 122.5. Okay, now notice here there's no remainder, and yeah, so that's illustrating the decimal rule. And going back, remember we've used the remainder rule where we've run out of zeros and we still have some left over, and we just say that, you know, that's the answer plus you've got some remaining. Now the next rule that is very important, which is what generally trips up a lot of people in doing long division, I like to call this rule the substitute zero rule. Okay, so let's, for example, take the example of 15,245 divided by 3. Okay, let's carry on with solving this problem how we normally would, and see when or how the zero substitute rule comes into play. So we'll take 2 of these numbers together, so 15. So we say off 3 times table till we get to 15 or close to it. So 133, 236, 339, 4312, 5315. 5 times 3 is 15. Subtract it and we're left with 0. We can drop the 2 down. We can only drop one number down at a time. Now we're left with 2. But now we've got a problem, right? So this 2 is less than this number 3, right? What can we do, right? We can't really use this 2 by itself. So the zero substitute rule comes here, and if we put a 0 here, we're allowed 1 0 or to put down. So as long as we put down a 0, we can put 1 0 down here. Now you might be thinking, well, why can't we put a decimal point, right? Why can't we just put a decimal point and then we'll be allowed 3 zeros? But remember, you can only use the decimal point if you have no numbers left. In this case, you've got 4 and 5 left, but you can't drop 4 and 5 because you've already dropped 2, if that makes sense. So when you've got numbers left over, you can't use the decimal rule. Instead, you put in a 0, which allows you to drop another 0 next to the 2, which becomes 20. Let's clear this up. So 0, you've put the 0 up here, and you can drop the 0 here. So essentially what you're left with is 20, right? So now you say your 3 times table until you get close to 20. So 133, 236, 339, 4312, 5315, 6318, 7321. 73 is too big, so we use 6. So 6 times 3 is 18. Subtract these 2 from one another, you're left with 2. Now 2 is too small, so we drop the next number down. So we drop the 4. Sorry, the 4, so this becomes, let's clean this up a bit, 24. And then again, same process, say your 3 times table till you get to 24. In this case, it would be 8. 8 3 is 24, right? 8 3 24. Subtract these 2 from one another, you're left with 0, and we've still got this 5 left over. So let's drop the 5 down here, okay? And 5 is bigger than 3, so we can use it on its own. So 133, 236, 23 is too big, so 1 3 is 3. Subtract 3 from 5, you're left with 2. And now Okay, now we can use the 0 rule because there are no more numbers left, right? We've used all of these numbers, and with this 2 down here is too small to be able to be used by its own because we're dealing with the divisor of 3. So what can we do? We can use the decimal rule. Let's put a decimal here, and we're allowed to drop 3 zeros. So drop 1 0 down, and we're left with 20. So 3 times table till you get to 20. So that would be 6, right? 6 times 3 is 18, and you're left with 2 again. You can drop another 0 down because 2 is too small. So we've put that decimal here. We've used one of the zeros here. We can drop it down here. So this will be our second decimal. Again, same process. 6 times 3, 18. Subtract it. We're left with 2. We can use one more 0. This will be our third 0. And so we say our 3 times table till we get to a number close to 20 or 20. So that will be 6 3 18. 6 times 3 is 18. Subtract 18 from 20, and we're left with 2. Right, now we've used the decimal rule, right? We've used all 3 of our zeros. This is where the remainder rule comes in. Remainder 2, right? Once we've used all our decimals and there are no numbers left over, we just put remainder. So remainder 2. So the answer is 50,681.666 remainder 2. Now I hope that clarifies some of the misconceptions that you may have had from the previous video. These 3 rules are pretty much the only 3 rules you need to be able to solve complex division equations like these and the ones above it. Thanks. I hope that's helped. If it's helped, please give it a like, subscribe, and let me know in the comments down below if there's any other videos you think will be helpful or you'd like me to do. Thanks.